Okay. All right, I should be live. Someone's going to have to confirm my existence as always. Whoa. That's apologies for that. Uh Literally the moment I was about to click play, our contractor showed up, the guy who's building our house, and we're doing a big concrete pour tomorrow morning, and so we needed to make sure that we had everything locked up and ready to go before we actually do that. So it's good news. We got approved by the Comox Valley Regional District where we live to actually build our studio. So the shop. So we're starting that. We've already started, and so the footings are ready to pour tomorrow, and then we do walls and then roof, and hopefully by December we'll have a much better space and I can be out of this accursed trailer. Man, trailer life sucks. I think, all those like aspirational videos that people have on the internet where people are like living in trailers, they're like, woohoo, we're living the good life. It's a lie. They're screaming and sad inside. Yeah. Pictures where it didn't happen. Yeah. I'll show some pictures at some point. It's just like a box on the ground. If you're building a telescope, yes, yeah. So once the shop is done, I will build a little roll-off observatory. Is my plan. I'm going to build a shed that you can roll away, and there's a telescope inside. I think is the plan, but we'll see. Are we going to 3D print the house? That'd be cool. No, we're building. There's a thing called ICF, insulated concrete forms, I think. And so it's like foam, concrete foam. Anyway, it's these big foam blocks, and then you set them up like Lego blocks, and then you fill the inside with concrete. And it's because we live in fire country where we are. So a normal house, if you build a wood house, it just burns. And with this, it'll actually keep us alive for about 4 hours or so before the house burns. So there's been plenty of forest fires that have come through exactly the spot in the past. So we're going with something that's a little safer. So, all right. Anyway, time to do my job. So let's see, before we get started, Astronomy Cast is back. So from those of you who are like, when is Astronomy Cast coming back? It already came back. We did the latest episode on Friday. The weekly Space Hangout starts in 2 days. It's going to be rough. We'll see how this rolls with using my studio for being able to do that. We've got... and then I've got 2, maybe 3 interviews coming later on this week. So I'll post them later on, but they're going to be cool. The Hycean Worlds, man, I don't even remember. Someone from NASA, and then this Enceladus rover concept. So hopefully we're going to talk about some stuff that none of us know about, which is going to be great. All right, let's get into this week's episode. Okay, so Chad, the recording reminder, I guess it doesn't really matter anymore because we're just posting it straight to YouTube. So yes, I am recording. All right, so as always, I've got a few prepared questions, and then we'll go into the actual questions that are getting from the live show. All right. Hey everyone, welcome to the question show. Your questions, my answers, as always, wherever you are across my channel. If a question pops into your brain, just write it down. I will gather them up and I will answer them here. Now, a bunch of people have been mentioning that I seem to be using a green screen. It is not true. There is no green screen that I'm using right now. I'm using the Zoom background feature. So it's not a green screen. In fact, I tried using a green screen and it sucked. So I've gone back to just using the Zoom background. And the reason I'm doing that is because I am recording from the back of my trailer. You do not want to see the messy bed and all of the junk that's piled up all around me. I promise you. So, but just a couple of months and then we'll be in the new studio and we'll have a lot more space and things will go a lot better. All right. So we do the show every Monday at 5 p.m. Pacific time. So if you want to join live, you can. But put down your questions anywhere across my channel and I will gather them up and I will answer them here. All right, let's get into it. Matthew Grotke. With LIGO, how do they tell between bigger collisions farther away and smaller collisions closer? Interesting question. One of the amazing things about... Let me do this again here. All right. LIGO, of course, is the gravitational wave observatory that has been detecting all of these merging black holes, neutron stars, black hole neutron stars, maybe primordial black holes. We don't really know yet. And LIGO is capable of detecting these events across a sphere of space centered on the Earth, of course. And so your question really asks is like, when we see a star that's very, very bright, how do we know that that star is just close or that that star is really far away? It's really hard to know which one it is. And so it's one of the really tricky challenges that astronomers have had to come up. And so they have this idea of luminosity. So when you have a star or a galaxy, it's going to have its absolute luminosity, essentially the amount of light that it is putting out. And then you've got its apparent magnitude, apparent luminosity. So from our distance, how much light are we receiving? And it can be really tricky to know whether the star is just close or it's far, it's just brighter. With gravitational waves, the way they determine the distance on gravitational waves is through essentially through redshift, in sort of the same way that they detect these galaxies that are moving away from us at faster and faster rates. This was the discovery made by Hubble. Hubble had to use a method to determine sort of these variable stars that were in these galaxies and use that as a way, as sort of like a ladder, a ruler to figure out the distance to these galaxies. And then they realized there was a correlation that the faster these galaxies were moving away from us, the farther they were, and you could sort of double check with these mirror variable stars. And I won't go into exactly how this works. I've covered this before in other ways. So with gravitational waves, it's purely based on the redshift. Essentially, as these two objects are spiraling towards each other and they're about to collide, they put out these waves, these gravitational waves that then sweep out through space and are detected by LIGO and other gravitational wave observatories here on Earth. And the frequency of those waves as they pass over, because they really are, they're like ripples in the ocean, and the gravitational wave observatory detects these ripples, detects the frequency as these waves pass over, and they're able to determine the redshift. In other words, if it was very close, you'd expect one frequency. If they're a billion light years away, you would expect a different frequency, and that redshift allows them to calculate the distance. And one of the cool things that was done with this ability with gravitational waves to detect distance is they were able to finally confirm the fact that gravity moves at the same speed as light. And so back in 2017, there was the kilonova event where you had these two neutron stars collided with each other. They let out a blast of radiation and gravitational waves at the same time. We saw the radiation and we also detected the gravitational waves at the same time, telling us that these things move at the same speed. So that's how they do it. Okay. Red ketchup. Are all the satellite rovers' engines that we sent on Mars landed or crashed? Have they all been sterilized? Even the first ones that are crashed been sterilized? No. Keep in mind that you've got the Americans with NASA, you've got the Russians who have been sending missions to Mars. They've all been crashing. The British sent a rover. The Europeans have sent, or British sent a lander. The Europeans have sent a spacecraft to Mars that's crashed. And so many of those spacecraft that were sent to Mars were sent earlier than sort of our modern idea of planetary protection. And so there were no real cleaning put in place. But eventually it started to dawn on NASA and the rest of the world's space agencies that there was a risk of microbes from Earth contaminating places like Mars, especially places where there could still be water or there was water in the recent past. There could be life there, and you want to make sure that we don't contaminate it. And so many of the rovers are sterilized the best that they can. Depending on where they're going to be going. So if it's going to go to a place that's very inhospitable, they don't do much of a sterilization job because it's very difficult. They essentially have to take each part of the rover, put it into an oven, bake it to an incredibly high heat, put the whole thing together in a completely sterile environment. It's an enormous pain. While if you're just going to build something that you don't have to worry about planetary protection at all, you can just slap it together. You're concerned about grit and dust and stuff getting into it, but you're not concerned about microbes, which, as we know, life finds a way and they get everywhere. So I would say the older stuff that's crashed onto Mars, a lot of the Soviet spacecraft, some of the older stuff sent by NASA weren't protected that well, and then stuff that's more modern have been protected a little bit better. And I think you're going to find into the future planetary protection is becoming more and more of a global, internationally agreed upon way of protecting Mars from our filthy microbes. Okay. Ruling Moss 55. Hey Fraser, love what you do. I have a somewhat obscure question. Say NASA or some other space agency proposed a sample return mission from Titan, similar to the Mars sample return, expected in the next couple of years. Would it be possible to make a launch vehicle capable of lifting off from Titan? Would the atmosphere be too dense to be able to achieve orbit from the surface? Would the high concentration of methane in Titan's atmosphere trigger some sort of explosion if we tried to use a chemical rocket in the lower atmosphere of Titan? So as you know, NASA is planning on bringing samples back from Mars. And the way they're going to do this is they're going to send a rocket to Mars. It's going to be empty of fuel. It's going to land on the surface of Mars, and then it's going to fill up. It's going to essentially create its own rocket fuel using resources that it finds on Mars. It's going to be sucking in carbon dioxide. It's going to be using a chemical process to with hydrogen to turn that into methane. It will fill the rocket, and when it's ready to return the samples, it will blast off from the surface of Mars and will come back to Earth. Well, actually, it's going to blast off the surface of Mars, meet a spacecraft in orbit, transfer the samples to that spacecraft, and that spacecraft is going to come back to Earth. But could you do the same thing with Titan? And the answer is yes. In fact, we did an article on Universe Today, feels like about a year ago or so, about exactly this, that there is a researcher who is who's put together a mission proposal for NASA on doing a sample return from Titan using local resources. And as you said, right, the local resources that you have on Titan, the mountains and the sand are made of water. They're made of just crushed up, this is again, on Titan, the rocks, the sand, the mountains, they're actually just made of water ice. The seas are made of liquid methane and ethane, rocket fuel in many ways. So you could go to Titan, you could land your spacecraft there, you could bring in water from the surface somehow, you could try to bring in carbon dioxide from the atmosphere, or if you could land close enough, or maybe if it rained, the methane rains, then you could collect that and turn that into rocket fuel. Now, you still need an oxidizer. And so that's the trick. And people always want to know, like, why doesn't Titan just explode? Because it's got methane all over it, and because you don't have the oxidizer. The oxidizer is locked away in all of that water. So you would need to split up the water using, say, electrolysis into hydrogen and oxygen, and then you could turn that then into rocket fuel. Or you could essentially use that hydrogen with carbon dioxide to make methane, and then get oxygen to be your oxidizer, have liquid oxygen, liquid methane, use those as your rocket fuel. And it would absolutely work. The gravity on Titan is fairly low, so it's actually very easy to launch a spacecraft off of Titan. The atmosphere is thick, so that would definitely pose a challenge, but it's not like Venus thick. It's like 50% thicker than Earth's atmosphere. So it would be a problem, but not that bad of a problem. And in fact, there's lots of interesting ideas because the atmosphere is so thick, the gravity is so low, you could, say, launch an airplane and it could fly to a certain altitude and then the rocket could take off from that. So you've got a lot of ideas. And hopefully, as I'm talking about this, Chad is putting up images of the article that we did on Universe today, so you can check it out. And I'll put a link in the comments because it's a pretty cool idea. And I don't think anybody else talked about it other than us. Clearly, I need to interview the researcher, don't I? Okay, so those were the questions that I had prepared, and so now let's go into the live questions. Okay. Matt Legros. Hey Fraser, love the show. Question for you. Being close to a large gravity field slows down time. If I found an area without gravity, how fast would time go? And what if I went there at the Sol? I don't know what Sol means. So I'm just going to, let's just chop it at the how fast would time go. Yeah, as we all saw in the movie Interstellar, you spend a bunch of time near a supermassive black hole, and for every day that you spend, 30 years happen for your friends and mother back on Earth. And so, I mean, even just being down here on the surface of Earth, we are experiencing gravity. We're experiencing time differently than astronauts who are in orbit. But the key to this whole thing is that it's about relativity. Everything is relative. So first, there's no place you can go in the universe that doesn't have gravity. You are experiencing the gravity from every single atom, every single photon, every black hole, every bit of gas in the entire observable universe. If you can see it, you're being influenced by its gravity. So there's really no place that you could go. But it all really comes down to the relative amount of gravity. So back to the idea of Interstellar, if you and your friend, your astronaut friend, were standing on the planet together, you would experience the same amount of time together. But if your friend was back home on Earth and you were down on that planet, then you would experience a day and they would experience 30 years. If you were, I don't need to give another example. So there really is no place that you could go that doesn't have gravity. Everything's just relative. And so when you ask this question, you've just got to say, compared to what? Where are you and where is the observer? Where are you and where is the person that you are comparing yourself to? You can calculate a difference of time between those two locations because of the different gravity wells. But it's going to be different for you and every other observer in the observable universe. Double D. After seeing a video of an astronaut losing a shield, I was wondering if the ISS could have a mini EVA RC vehicle to go retrieve lost items. That's a really cool idea. And to be honest, I don't know of anything that's been proposed to fly around outside the International Space Station. There have been flying robots that have been sent to the space station to fly inside. Essentially, they're very reminiscent of Star Wars. They're like these little balls that can shoot out little gusts of air and maneuver themselves around inside the space station. But they're pulling in air from the space station, they're blowing it out again, and they're using that to maneuver themselves around. But you need something with propellant to sit around outside. Back with the space shuttle, Bruce McCandless, one of the astronauts, there's a very famous picture where he's floating free in space with this backpack on. And so for a few of the missions, they gave the astronauts a backpack that would allow them to fly around untethered to the space station. But there aren't a lot of uses for it, and so it's not really a necessity. But I wonder if there are any plans to have some kind of spacecraft, just some kind of utility vehicle that's attached to the space station that could do this kind of work. But I don't know of anything right now. Pole Took. I read recently about a mission that's going to flip some asteroid orbits around another asteroid to study our ability to stop them. Can't recall what the mission was. Does anybody know? I don't know the specific mission, but there's the DART mission that NASA is building right now. And the purpose of this mission is to impact an asteroid. And from that impact, NASA will be able to understand how how much mass they have, how hard they are to move. And so you can imagine this spacecraft will smash into this asteroid. They'll measure its trajectory beforehand, measure its trajectory afterwards, and be able to just get a sense of how much effort, how much energy we can from Earth put into an asteroid to try and move it. And of course, this has a real impact on, pardon the pun, on the dangerous asteroids that could be coming to Earth. The thing with asteroids is that it's not like we're going to detect some asteroid on a collision course with Earth. It's that there will be an asteroid that is, say, 50 years down the road, has a potential to interact with the Earth's orbit at a bad time. And there'll be some percentage chance, some probability that that asteroid is going to smack into us. And so you've got many, many years. And so the question is, if you've got lots of years, what is the most efficient way for us to be able to try and change the trajectory of that asteroid just a little bit to be able to have it not be in the danger zone, the high probability zone of hitting us? And that's what missions like DART are going to try and help us figure out. Arjun, you're going to get solar panels and a place to charge your leaf. Eventually, I'd like to get solar panels, but we're pretty lucky. We're able to get hydro. So a lot of the people, in Canada and British Columbia, we call electricity hydro because it's all comes from hydroelectric. And but many of my neighbors couldn't get electricity. They had to go solar because it was going to cost them like $1 million to get electricity. But I'm really lucky. Where we live is pretty close to the road, and so it wasn't that expensive for us to be able to get electricity. So maybe down the road, we'll do it. Eric 1, have you heard about the Unistellar EV Scope 2? I haven't heard about the EV Scope 2. I mean, we've talked quite a bit about the EV Scope, as well as the, I forget the name of the other, Vaonis, the other company that's doing it as well. These are the future. I mean, I love the idea of these automated telescopes, and anyone who's in the telescope building business right now should be building automated telescopes like what they're doing. There's going to be it's so much of a hassle to polar align a telescope to the point that you just don't want to do it. You don't even want to try. You set up your telescope, it doesn't point where you want, and you just go, I don't care anymore. I didn't want to try. So these are going to be the way. What do you think about the new film on the ISS? I haven't seen it. Evie Scott and Flower, it's very detailed questions about these. Your questions are like questions you should ask everyday astronaut, because I don't know about what they're doing, or like Scott Manley, all the details of liquid nitrogen, and then I don't know about birds being a potential danger to Starship. It was launching, chunks of foam would fall out of the main fuel tank, and we saw with Columbia, it impacted the wing hard enough to destroy the spacecraft as it was trying to re-enter the atmosphere. But Columbia was made of aluminum, while Starship is made of steel. So I don't really know. But the jet, the problem is a bird going into the jet engine and making a mess of the actual complicated machinery, while you're just worried about this sort of an impact of a bird. What size a bird? So I don't really know. Okay, right. The Russians are sending a team to shoot a film on the space station. Will that be better than Tom Cruise's Mission Impossible? I think the Mission Impossible one will be better. I'm just guessing, but who knows? Okay, let's do this one. Raphael Dominichini. If space probes did not have size and weight limitations, would it be possible to build them cheaper? I like this question because this has never been a possibility for us up until this point. Hold on, I don't need that anymore. It's funny. Okay. All right. I like this question because up until this point, no one would ever ask that. Like, the cost of the rocket, the launcher for your spacecraft was so expensive that you had to absolutely minimize the weight and cost of your spacecraft. You absolutely had to minimize the weight and size of your spacecraft to fit within the fairing, to be able to launch on the spacecraft. And every kilogram that your spacecraft took up was going to cost you tens of thousands of dollars to launch. And so you had to be really, really careful. The more you could shave off weight. And so a lot of the times back in over the last couple of decades, there was just a ton of compromise that had to be made. Really cool missions, really cool instruments had to get thrown overboard because they couldn't be, they were too heavy. And we're talking like things that are like, I don't know, 5 kilograms, 10 kilograms, like very light instruments, but still couldn't fit within the weight. And now you got these new, like, even just with the Falcon 9, with the reusability of the Falcon 9, the low cost, the Falcon Heavy, you've got the ability to be less careful about shaving down the weight of your spacecraft. And when Starship comes along and you're going to be launching your spacecraft, you're going to be launching 120 tons or whatever to orbit for a couple of $1 million, theoretically, it changes everything. Like, you just don't have to be concerned about it. And so you can then make a heavy spacecraft that is cheap. Or you can make a big bulky spacecraft that is cheap. And so I think that we're going to see, like, what a revolution in launchers is going to provide is a dramatic decrease in the cost of spacecraft. And a cheaper cost means more complicated spacecraft going to various places. And so, I mean, I just imagine, like, if James Webb was designed for Starship, it would be a very different instrument and probably would look similar to Hubble and not the way James Webb does. But so I think that we're going to have these compounding effects that are going to change everything. And I can't wait to see this play out. If it happens. Come on, Starship. Launch already. What are the first few things James Webb will be observing when it's launched in June 2032? That's a great question. I don't know the answer to those off the top of my head. But there's NASA has been releasing a series of press releases about this, and I tend to just avoid them because I don't know. It's just like kind of like I'd rather talk about what it has observed than what it is going to observe. Like, we've talked about it in broad strokes, but NASA's putting out very specific stuff. Like, it's going to tell us more about white dwarfs, or it's going to tell us more about brown dwarfs, or these kinds of planetary atmospheres and things like that. So I don't know the actual specific list of things, but it's only in December. It's not June 2032. Or is it? Um, hmm. Vignesh Gopinath. I assume we conduct experiments on ISS because of microgravity. What kind of scientific experiments would happen on a moon base, and why that could only be done on the moon and not on Earth? I've never thought about this before. I love this question. So what could we do with a moon base that we couldn't do with Earth or with the International Space Station? And you're right. I mean, the main purpose of performing experiments on the International Space Station in microgravity is to learn what microgravity does to materials, to electronics, to life, to plants, to cells, all kinds of things, right? You just want to understand, how is microgravity different than gravity? And turns out very different. We found all kinds of things. And there have been a few experiments that have been done to say, is there something that you can do in microgravity that you can't do under gravity at all? And they've found that you can like grow crystals, you can make fiber optic cables which are pure, that are able to send signals better. So there are a few advantages to being in microgravity. But if you're on the moon, you've got, say, 1/6 Earth gravity. What does that get you, right? And so I think the vast majority of the experiments that will be carried out on the moon will be, what does 1/6 gravity do to electronics, to life, etc.? It's going to be about learning how to live on the moon. There are going to be some experiments, definitely some astronomy research that can be done, cosmic ray detection. But again, that's kind of like, how can we live on the moon and deal with the cosmic rays? I guess it would be like, if we could perform experiments with biology on the moon and we could see that, say, you could take mice to the moon and they could carry their pups to term and they were healthy, then that would tell you that Mars, which has a heavy, more gravity, is probably safe as well. So I think moon is kind of like an extreme place, and you can find out everything that breaks spending time in low gravity, that then we would still have to test those out on Mars. But all the stuff that still seems to work out okay, we could assume that when we go to Mars, that stuff is going to work out okay as well. So I think that's what it's good for. But it's a great question. Tropical Tom Garcia, can you interview James Kirk while he's in space? Oh, that would be great. But he won't be in space for very long. He'll be in space for like 5 minutes, mostly falling. So if you haven't heard, of course you've heard, but William Shatner is going to be launching next week on Blue Origin, which is cool. How awesome is that? He's going to be 90 years old. Have I bought my mountain bike yet? No, I have not. I don't have a place to put it. All right. Sean Marson. Hi, Fraser. At the eventual heat death of the universe, will there still be time? If there's no particle left to decay, how would one measure time? Thanks so much for the show. This is a good episode. There's a pile of questions here that I've never even thought of, but that's a really great question. So as we look into the far, far future of the universe, and of course, Katie Mack has done an amazing book called The End of Everything, which she covers all of these issues. But for deep time, all of the stars are dead. All of the black holes have evaporated. One of the big questions is then, does matter, just protons, do they decay? And if protons decay, then you just won't have anything. There won't be any matter left in the universe, but there will still be the radiation and the various particles left over from the decay of the protons. And they will all be spreading apart in the universe, just indetectably warmer than the background of the universe, which will be close to absolute zero. It will be a very sad, dead, cold place. But will time still exist? Sure, time will still exist. I mean, Does time exist if we don't measure it? I think yes. I mean, unless you think that humanity is incredibly important. And so just because we use a clock to measure time, or whether we use an atomic particle to measure time, doesn't mean that time isn't still taking place. Of course, back to that earlier question, I mean, it's all relative where you are, what kind of gravitational influence you're under. But yeah, time will still go on forever and ever and ever, as the universe expands and cools and dies even more. Have a nice day. Zach Perry. If a rogue planet was heading towards our solar system, could it catch us by surprise, or would we definitely know well in advance? It, of course, depends on the size of the rogue planet that is on its way. But, I mean, right now, let me do this again here. So, all right. Mike Brown and Konstantin Batygin, of course, they have suggested, they have calculated that there is a heavy object out in the outer solar system, something Uranus, Neptune sized, way out beyond the orbit of Pluto. And yet, so far, we haven't detected it. And so it's in the solar system. It's well within the solar system. If it's there, it's relatively close compared to the nearest star system. And yet we haven't been able to take a picture of it yet. Probably when the Vera Rubin Observatory comes online, we'll finally get that image of Planet 9 and maybe Planet 10 and Planet 11. But we're still waiting for those the telescope to come online. So yeah, I think we probably like I'm just sort of imagining if there was an object the size of Earth, we probably wouldn't detect it. Like, no one would notice it until it was probably around the orbit of Pluto, maybe even closer. You know, Pluto was found through a search. You can find Pluto in a backyard telescope, but you got to know where to look. And so until you have these all sky surveys that are going really updating every couple of nights, you're just not going to be looking at every part of the sky. So it's going to be a chance. So if there was an Earth-sized rogue planet on its way through the solar system, I don't think we would spot it until it was reasonably bright, started to get picked up by accident in a lot of the images that astronomers are taking, kind of in the way that supernovae get detected. Someone will be observing a galaxy and then they'll notice that one of the stars is a little brighter and like, I discovered a supernova, or the way people find comets. And so it would need to be relatively close, though, probably within the orbit of Pluto, maybe closer, before it got detected. Joel Mockjay, do you believe in the Fermi paradox? I feel like half the videos, half the questions I've ever answered are about the Fermi paradox. So, yes, I believe. I mean, does one believe in the Fermi paradox? I don't know. So the Fermi paradox, of course, the universe is big and old, and life is everywhere on Earth, and yet we don't see any life. Where is it? I don't think it's out there. That's my take on the Fermi paradox, is that I think we're alone in the universe. But that's a very quick answer. And if you search for the words Fermi paradox on my channel, you'll get many examples of me answering that question. Many, many, many. Ravi D asking, can we find neutron star material? Like, are you talking about like can we find stuff here on Earth that came from a neutron star? All right. Matt Jono 2. Would it be better to send a lander that builds its own rovers? Say, a lander that has one pre-built rover that gathers material while the lander builds more rovers that could then explore all of Mars. You are talking about von Neumann probes. You're talking about self-replicating robots, which would be awesome. If we could send spacecraft that would go to Mars, and it would have just the bare minimum to be able to exist on Mars, and then it would gather all of the local resources and begin building more rovers on Mars. That would be the greatest. I would love that. But unfortunately, we're just not that technologically capable yet. 3D printing in space has just barely been tested out on the International Space Station. There's some ideas, and you could build physical elements. You could build, say, legs, joints, things like that. But to build some of the more complicated parts, the machines, the actuators, the computer board, things like that, that would be really tricky. So I would say we are decades away from that. But the idea of sending a spacecraft that has like the main parts and then gather stuff from the local resources to build more of itself, or copies of itself, I like that idea a lot. But I wonder if it just makes more sense to just build the thing on Earth, be able to test it out, make sure that it's right with good equipment, good machinery, because sending it to Mars and having it try and make a copy of itself or making sub rovers, it's a pretty bad workspace for your poor robot. Like, it's out in radiation, hot and cold. It's only got the terrible tools that you sent it with. But there will be a time. Like, there will absolutely be a time in the far future, near future, far future, when spacecraft go to other asteroids, planets, things like that, gather up material locally, and they're able to make copies of themselves. It would be really cool. I can't wait. It's like we are Legion, we are Bob. I am Legion, we are Bob. We are Legion, I am Bob. Anyway, the Bobiverse. It would be like the Bobiverse books. Okay. Jim Katzaman, how can they tell if it's two black holes merging, a black hole and a neutron star, two neutron stars, as opposed to simply two really big things that shook up the place? They're able to detect the frequency of the gravitational waves as they're coming together. It tells you the mass of the two objects that are moving around each other. And black holes have a minimum mass that they have to be. And so if it's below that minimum mass, then it has to be a neutron star. So really, it's just like if you measure something with a mass, neutron stars are here, black holes are here, and they don't overlap. And so you can tell from the masses of the objects that collided what they were. Oh, there you go. SOL, speed of light. I thought it was like shit out of luck. Darsh Bahani, is there a thing that can travel faster than the speed of light? Not that we know of. Arjone, would Hycean worlds have ice covering the rocky surface? I don't know. Let's talk to the researcher on Thursday. We'll ask all these questions. So, Roy Lindsay, why don't launch platforms have huge holes beneath them for all the exhaust? They do. The launch platforms have... Actually, I'll answer this one more. Okay. Roy Lindsay, why don't launch platforms have huge holes beneath them for all of the exhaust? Launch platforms do have large cavities underneath them for the exhaust to go. When you look at, say, the space shuttle, and the space shuttle is taking off, and it looks like it's just sitting on this launch pad, the reality is that it's got this huge area underneath. And in fact, when the space shuttle was launching, they would spray water into this area as the rocket was firing its engines, and sort of has two parts. One is to dampen the sound. So it would be like it would absorb all of the sound from the rocket so that the rocket wouldn't shake itself apart, but also to absorb a lot of the energy, all of this heat and exhaust that's coming out of the rocket. And so all modern launch pads will have some version of that. They're not just sitting on the ground. They're launching from some place where they can deal with all of the exhaust gases that are coming out of the rocket. Okay. Ethan Archer, do you have an educated guess why we haven't, at the very least, sent supplies to the planned landing site on the moon when we go there? We need the supplies. It's just the next step. I mean, the plan for Artemis is they're just going to send the astronauts to the moon. It's the moon, right? Yeah, they're just going to go send the astronauts to the moon. They're going to get out, take some pictures, take some samples, get in the spacecraft, come back, leave stuff on the moon, and then they'll send more stuff, and they'll send more stuff, and they'll build up the capability of what's on the moon. So we're just sort of at the very beginning stages, but eventually, yeah, there will be cargo missions sent, just like how missions are sent to the International Space Station. Jack Malone. Okay, I'll do this one here. All right. Wow. So I gotta figure out. So what is my favorite? Which Fermi paradox solution is my favorite? Most likely solution, my favorite. Okay. Jack Malone. What Fermi paradox solution is your favorite? Not the most likely solution, but your favorite. Of course, I've talked about this many times. The answer to the Fermi paradox, the one that I hope is true, is that we're alone. I don't hope. Let me do this again. The solution to the Fermi paradox that I suspect is true is that we're alone. The one that I fear is true is the great filter, that something horrible happens to every advanced civilization when it reaches the rudiments of spaceflight. But what's the one that's my favorite? I would say the galactic zoo is my favorite. The idea that there is an advanced civilization all around us, that they are aware of us, that they are watching us, and they are waiting for us to reach some point in our development, which point they're going to make contact with us. Kind of like Star Trek. I mean, I've definitely been influenced by Star Trek. This idea of the prime directive, that you don't interfere with civilization until they've reached a certain level of technological advancement. They're attempting to reach out to other worlds, and that's the moment when their curiosity is at the highest, when they're open to finding out what's out there across the Milky Way, that you interact with them and tell them the truth. And until then, you just keep the wool over their eyes, make them think that it's all up to them. That's the idea that I like the best. But, it's probably because Star Trek just sort of messed with my brain. Okay, so I hate to do this, but I've actually got a roll. Yeah, so I apologize that this one was shorter, and I'm not able to stick around and do the after time, but we'll be back on Wednesday with the weekly Space Hangout, and then on Friday with Astronomy Cast. So hopefully we'll have a lot more of this. But thank you, everybody, for hanging out today. I've got to do the outro, and then I got to roll. More questions in a second, but first I'd like to thank our patrons: Bonnie Sandler, Mark Greenberg, Jeff Rennicke, and the rest of our 786 patrons for their generous support. Want our videos early with no ads? Join our community at patreon.com/universetoday. If you want a single comprehensive resource for space news, you'll want to subscribe to my weekly email newsletter. Every Friday, I send out a magazine of space news with dozens of stories, pictures, brief highlights, and links so you can find out more. Go to universetoday.com/newsletter to sign up. It's totally free. And did you know that all of my videos are also available in a handy audio podcast format so that you can have the latest episodes as well as special bonus material like interviews with me show up on your audio device? Go to universetoday.com/audio or search for Universe Today on iTunes, Spotify, or wherever you get your podcasts. I'll put a link in the show notes. Thanks to all the moderators, and a special thanks, as always, to Chad Weber and Nancy Graziano. All right, those were the questions this week. Thank you, everybody, for sending them in and for the people who joined me during the live show. This is super fun. I really enjoyed a lot of questions that I'd never seen before, which was great. So thank you, everyone, for hanging out. I will see you next week. Okay, so sorry, everybody. I got to roll, but thanks for the fun, and we'll see you all next week. Thanks, Nancy.